So to start the study of all of these the electric circuits, magnetism, integrated circuit, we need to know first the major components. So we're going to start with the major components. A quick review of the before we be discussing in the this chapter about the electric circuit. So I put the title electric circuit components and basic equations. Um, we'll be discussing first with the units. We are completing the little by little what we call the SI units. If you remember from day one when we discussed about international system, so I'm gonna refresh again everything here about these units. So there are seven. The first one is this is not there is no order, but just giving you as they are coming in my mind. First one is about the masses. So we're gonna use always the masses, and the unit for mass is kilograms. The second one is length. So we use that also. So the unit for length is a meter. Number three, the temperature, we didn't do that too much, but temperature is expressed in Kelvin. Number four, the time. The time is expressed in seconds. The unit when you calculate velocity or acceleration, you remember we use always the time as in a second. Number five, that would be the amount of substances that, but we will see that when we study, for example, the nuclear chemistry. So this would be in moles. Number six, we're gonna discuss about that today, which is the electric current. Electric current, and the electric current is expressed in the letter I, and the unit is amperes. The seventh one. The seventh one is about the intensity of light. I will just, we won't see that even if we study already the lights. So the intensity of light, this is expressed with the unit candela, so CD. So now today we are focusing especially on time and also on the electric current, on those two things. So we're gonna start with the major components first. So we're gonna start with the major components and also with the different symbols. So the first one is just let's say just a straight line. So what is the straight line about? This is representing a wire. So when we see straight line, we are showing a wire. That's like a pipe, water pipes, for example. That's a pipe where the electric current is moving the charges. This one is for what we call the resistance. So this is for resistance. The next one is a switch. So a switch is represented like this. So we can have, for example, a wire. So this is open switch. So this is a switch. And when we connect it, so for example, when you connect those two, then it is on. If you remove the connections, then that would be off. Okay, so that's a switch. Next one, when we see this symbol here, just like a filament, but within a bubble. So this is, of course, that's a lamp. This one here, a wire, and then you have something like a symbol, like a letter S. That's a fuse. A fuse is used to stop the to cut off electric current to pass through a circuit in a case of overheating or so. Okay, next one is this one here. This is for semiconductor. And you see, we're gonna study that later on, but you see this is like an arrow. So this is a big arrow, and on the other side, so that means the electric current would pass through only in one direction, following this direction. Here is another one, very important also in a circuit. We call this battery. So in the case of a battery, this is two lines side by side. One is a big one, and the big one would have a charge positive. The short one would have a charge negative. Now, very important to know in this case is if you have a battery, the direction of the current. I'm going to talk about the current after this one here. I will represent the current with the letter I. The direction is out of the. You start off from the positive, and you end up the circuit to the negative. So that means you're going to go around and end up this way. This is what you call the electric current direction. Now, on the other side, if you go from the negative out, this is the direction of the flow of electrons. So that's to make sure that you see those two distinctions here. To distinct things here: electric current direction, positive to negative outside the circuit; electron flow, negative to positive outside the circuit. And the last thing I would like to add here before we move on is just in case you have a wire, if you want to express to show the current is passing through a flow of electrons, a flow of charge, then we use the letter A. So the unit for current is amps, amperes, but we're gonna use just the big A to express the unit. And finally, I will give you three or four equations, major equations for now related to all of this. So we're going to start with the electric current. Electric current I. So again, the unit for this is amps, A. Electric current is the total charge, the amount of charge. So charge is in coulombs, C, passing through a circuit in a given amount of time. So this is in second. So these are the units, coulombs per second. So that's the major equation for electric current. Now the second one is what you call the Ohm's law. So Ohm's law is V equals RI. So you see here again the electric current. R is a resistance, and V is a voltage, difference of a potential. So this is Ohm's law. We're gonna see that we're gonna use that very often. Related to the Ohm's law, we can also talk about power. So power, which is in watts, equals R I squared, which is also, so let's say power P, also VI. So those are the two equations for the power. So actually there are more than two. So that's number 3. Number 4, if we calculate the equation number 4, if you calculate the energy, so I'm going to write it as energy here. The energy would be Q multiplied by epsilon. So what is epsilon? Epsilon is, we call this electromotive forces, or EMF, represented by the Greek letter epsilon. This is not exactly a Roman character, but that's, we've studied these Greek letters. This is epsilon. So what is R? R again, R is a resistance, and R is a resistance. So the R is expressed in ohms, the unit is ohms, and so we have all of these. That's the main important part. You're gonna see this in details. R, I, P, V, and T, Q. All of these. So R resistance, I electric current, Q charge, T times, V difference of potential, P power. And the last unit, last equation I'm gonna give to you is R equals rho L divided by A. This is used, rho is, this is a Greek letter again. Rho is resistivity, and this is used to calculate. If you are focusing uniquely on circuit wires, etc., then these are the basics. But you're gonna see more in the future.